Hello everyone, my name is Wei Songwen. I'm a teaching assistant of this class. In this video, I'm going to introduce the implementation of the code to solve the past planning problem based on Dr. Xu lecture. In this past planning problem, we got two additional constraints. The first one is the time consuming area here, and the second one is the fuel consuming area here. So the objective is to find a trajectory with the, the summation with the overall smallest cost trajectory from the start point to the destination point. Okay, let's go to the code. The major difference is we need to set up additional boundary. The time consuming area here and the time consuming area here. Corresponding to the code is here is the fuel consuming. Actually, the code I will submit the code to the GitHub page here, and all you guys can download the code through this link, through this item. Okay, and download to anywhere you want. Okay, I also add a lot of clear comment to the function blocks here. For example, here you are going to set up the time consuming area corresponding to this one. Okay, this is the time consuming area corresponding to the core here. And the fuel consuming area corresponding to the code blocks here. Okay, the same to our last video. We introduced this one is for the visualization to draw a result, to draw the boundaries. Okay, we are going to do the same thing. Initialize a past planner class using this is the obstacle. Obstacle is the black dots here. It's the boundary you cannot touch. And it's grid side, the radius, and here is the fuel consuming area, the x-axis and the y-axis, x-axis for the time consuming area. And after we initialize, we can do the same thing, go to the past planning pair. Okay, in this part, there are two things we need to focus. The first one is how to calculate the heuristic. This is slightly different from our previous basic A-star core in our last video. When we calculate the heuristic cost, we need to multiply the cost for per grid based on the formula here. Okay, because based on this problem, we are going to apply the A-star past planning algorithm to the flight planning. Each grid should have a the cost of each grid have a physical meaning. The physical meaning is calculated based on this formula. Because in the last A-star algorithm, our implementation is based on, okay, wait a moment. For each grid, the cost is 1. It's unit 1. Okay, for example, 1 meters. But in this past planning task, for each grid, its physical meaning is calculated based on this formula. So it's slightly different. So therefore, we need to change this part. Okay, this is for the heuristic calculation. And the second part we need to change is when we are calculating the exact cost, this one, the GNM, this one is actually the XY, the position of a specific node. And how we calculate, it's based on the distance multiply the cost, what I mentioned previously, the physical meaning for each grid, multiply the distance. For example, the grid is 1 and here is 1, and multiply the cost of per grid calculated use this formula. Okay, and then we can get all the cost to search for the final part. I have to say this one is almost similar to our previous video. Okay, introducing the A-star algorithm using Python. only the two things we need to change, three things we need to change. Okay, in overall, I emphasize again. The first part is we need to initialize, we need to set up the two spatial area, the time consuming area and the fuel consuming area. And the second thing is to, okay, after we initialize, the second thing is like how we calculate the heuristic cost. It's slightly different because we have assign physical meaning to each grid. The cost for each grid is calculated. Oh, sorry, actually it's based on this one. And all the parameters we will provide through this table. Okay, for example, for this variable, it's one. For this aircraft model, it's 1, 1, 2, 5, 10, and for different aircraft model, the value is slightly different. So the only thing actually for you guys, the only thing you need to modify is here. We need to modify the value of each parameters here. For example, the parameter set here is corresponding to this aircraft model, Polio A380. Okay, let's say if it's 1 and say T is 2. Okay, for example, if I'm going to using this one, the parameter should be changed slightly. And okay, we run a code to see what is the planned route. Okay, you see, in this parameter setup, the planned route is interesting thing is it directly goes through the time consuming area, but it avoids the fuel consuming area. That's why, because the penalty cost of the fuel consuming area, the yellow one is pretty high. It's 20,000. So the past planning A-star algorithm tend to avoid getting into this area. So the trajectory is like this. But for the additional cost, also we call it penalty. For the time consuming area, it's pretty small. It's only 0.2. So it's choose to go through this area and find a shortest. It's not, we should not say it's shortest. It should be the path introducing the smallest cost, like this. Okay, for example, if we choose this value as pretty high, for example, 10,000, and we run again to see what will happen. Okay, interesting is that if we set this area, the cost is pretty high, it will avoid getting into this area and finally find a path like this. And what will happen if we choose this to pretty small? Both are pretty small, 0.1, and we run the code again. So it will search into this area and also search into this area. Okay, it will directly go through this time consuming area and also go through this fuel consuming area. So it pretty depends on how you set the value. I mean, how it will, the cost. I mean, it fully depends on the cost of these two area. Okay, the path planning algorithm will plan through thoroughly different trajectory if the cost is differently. Okay, I believe, okay, that's all for the call here. If you going to use different model, what you need to do is choose this part. I think you guys can try to change it with different parameter set here and to see what will happen. Okay, I also upload the code to the GitHub repository for you to download. CD. Also, if you guys still not familiar with, okay, CD test. If you guys still not familiar with how to upload the GitHub, upload your code to the GitHub, you can still follow this video. Okay, Airfield beauty. Okay, it's not. It will not be a big problem. Commit. For a star. In what? In flight. In flight planning. Okay, seems okay. Okay, push. Okay, you see, this code is the original A star. Oh yes, this one is the original version for A star algorithm, and this one is the modified version considering the time-consuming area and the time-consuming area and the fuel-consuming area. And you guys can only choose to modify this part, and you will get different kind of trajectory, a different kind of planned trajectory. Okay, I believe that's all for this version of the code. And also an interesting thing is also you can change the boundaries. For example, let me see. Okay, I will modify the cost to make sure it will at least award one area. For example, the time consuming area instead of pretty high cost. And in this way, the A star will award to get into the time consuming area. And okay, let me check first. Check it first. Okay, it will award to get into this area, the time consuming area. Okay, the trajectory is like this. It award getting into the time consuming area, and we can try to modify the time consuming area to make it larger. You see, it's from 5 to 20. The x-axis is 5 to 20, and the y-axis is from 15 to 30. And we can try to modify it from 0 to 20, and let's see what will happen. So you see, the time consuming area starts from 0 to 20, and it will also will award this time consuming area, and also it will get into the fuel consuming area because the cost in this area is pretty small. The additional cost is pretty small, and also even we can change it even smaller, -3. Okay, close it first. Okay, -3. It will go through like this. Oh, so even the cost in this area is pretty high. If you go through this way, the distance cost will also be pretty high. So finally, the A-star algorithm choose to go this way. And okay, we choose. Okay, modify back to 5. And also we can modify the y-axis, for example, modify to 40, and we are going to see what will happen. 40 means it from 15 to 40. The red area will like this. Okay. Okay, we can take a look. Okay, it will also still award to getting into this area and plan a trajectory like this. Okay, I think you guys can also modify this part. This is the fuel consuming area with the same methods. Okay, if you guys got any questions, please feel free to send email to me. Okay, let's send email, send office location. Okay, thank you. Hope you enjoy this video.